So, welcome to another episode of the Decision Clinic with me, Paul Gordon. And looking at my notes, I see my next patient is fascinating. His name's Will Cosby. He's got a job title as CTO, Chief Technology Officer, for what looks like a new tech startup company called Unseen. And it says here in his history that he's an astrophysicist. So I'm fascinated by the conversation I'm about to have. I have no idea which way it could go. We can look at the decision making of the universe all the way down to how technology supports decision making. So I'm excited to see what Will has brought to the Decision Clinic. Welcome, Will. Thank you for joining me in the Decision Clinic today. And great to have you with us. And what I find really helps me when helping with the decision making is to understand how people in my clinic make decisions themselves, how they tick. So I'd love to hear a bit of background about you. What are you up to at the moment?
Awesome. Yeah. Thanks for having me. Much appreciated. I'm Will Cosby. Like Paul said, my background's in astrophysics. I'm currently the CTO and co-founder of a company called Unseen. So in a nutshell, we're an AI architecture for alpha capture and creation, specifically building hybrid AI systems for decision-making, starting in real estate and then eventually broadening out. So that's where I've ended up. We'll back up quite a bit though. When I was studying astrophysics, how I actually got into that was I watched like a Nova special on black holes. And after watching that, I was just kind of like, this is the coolest thing I've ever seen because I understand nothing of what was just said to me. So I was like, all right, I need to now learn about that. Then what I was deciding on was I going to study nuclear engineering or astrophysics, and then decided that astrophysics kind of sounded cooler, to be frank. So like some of my decision-making process is certainly driven by, hey, this sounds like a really cool thing to do and sounds really interesting to be involved in. Once I got into astrophysics, I finished my degree a little bit earlier, started playing around in computer science, ended up discovering at the time it was just information retrieval was still the tagline for it, but it was basically precursor data science. Part of the decision to go into that was the math is a lot easier in data science than it is in astrophysics, and programming is really fun. So that was like a really easy jump to make. So I started studying data science, tried to start my own company right out of grad school. It didn't quite work out, partly because we didn't know how to actually build like businesses around any of the technology we were making. So we could build a lot of cool tech, but like the barrier we hit was how do we make the cool tech actually like useful day to day in the real world? So left that business, got another job specifically to learn like, hey, how do startups actually run? How do you get these things off the ground? How do you make them applicable into everyday life and like real companies? Did that for a while, moved to Singapore, moved to Australia, started my own business. So it's been quite a kind of branching road.
That is definitely a branching road that's brought you here to the Decision Clinic. So one of the things I'm going to ask you in a moment is what actually has you specifically come here. So what's a decision that maybe you're grappling with, but a lot to unpick in just what you said. And I always like to see what we can learn from people who come into the clinic around decision-making in general, and for people who are listening, what they can resonate with. I heard two things you said that struck me as your decision style, certainly in the earlier part of your career, which was cool. So there's something that says, this is cool, I'm going after it. And fun. So interesting to point to, because a lot of people would go, you can't make decisions based on stuff that's cool and stuff that's fun. Yet one of the things I know is if we make decisions that don't consider those things that are important to us, we end up in all sorts of places. We wonder how we got here. I think that's awesome. There's probably something else in there that has you go, actually, my own business is the way forward. Can you talk a little bit more about that as a decision?
Yeah, for sure. I think for me in particular, I have a real strong focus on things I enjoy doing. It's just super easy to spend a ton of time there. And that's nothing revolutionary for anyone. Everyone's going to agree with that. I've been fortunate in a lot of what I think is cool and interesting aligns with stuff that has quite a bit of value. So computer programming, data science, working with data generally. So a lot of it has been, hey, there's this really specific thing I'm really interested in. So when I got into starting my first business, that was in natural language processing. And this was before the modern transformer architectures. So in 2018, there's a paper published called Attention is All You Need, which is a great kind of tagline for people generally. But specifically,
it's a marketing paper, isn't it, or not?
Yeah, exactly. So specifically, that paper was introducing the modern attention mechanism that works inside of transformer architectures, which is a form of neural network. And that's what's made large language models like really possible today. This was before that, and we called them long short-term memory networks.
Long short-term memory networks. That sounds like an oxymoron.
Yeah. It was a really confusing architecture. Basically, instead of having this attention mechanism, which works pretty similarly, it's just a lot more efficient. Every neuron you had in your network would get passed over a sequence of words, and you're basically trying to keep a memory of all the words you've seen, so a long memory, but then also have your attention primarily focused on the kind of window of words around where your model is currently reading. So that's the short-term bit of that. When I was starting to get interested in that, that really kind of led me down a rabbit hole there. When I was in grad school, some of my courses suffered because I was no longer really interested in that. And I was spending most of my time in grad school researching this other stuff that we weren't really touching on at all in our actual coursework. It became a big part of the general research I was doing at that point in time. But it was definitely a situation where I had some of my professors come to me and say, hey, Will, there's something going on in some of your other courses. And I was like, yeah, but have you seen this? So there's definitely been a part of that that's driven a lot of my decision making. And I think another really primary driver of it is every time I'm coming up to a decision, I'm really looking at it from a how flexible is that decision I'm about to make. So like jumping from astrophysics into computer science was a really easy jump because computer science is incredibly general and you can do a lot with a relatively narrow speciality. And then you can combine other stuff into that. So that was a no-brainer to make that jump because it was such an obvious, there's a lot of different ways I can drive this decision if this doesn't work out. A lot of how I make decisions around my career progression over time was pretty much hey, if I take this opportunity, is that closing any doors or is this giving me like a lot of flexibility to do other things? And I would drive a lot of kind of where I would take my career off of that decision. And also now imply that a lot into how we're making decisions around our company and our technical disciplines, what structures we're building when, like what databases are we using. A really specific part of that is we have a lot of our kind of core databasing architecture operating around Snowflake. The platform generally is able to integrate with any SQL-based database. Snowflake just gave us a lot of scaling capabilities really early on that we didn't really have to spend any time thinking about. But we also have it as a very kind of cordoned off part of the platform where we basically just have one piece of code overseeing the connection, but all of our query construction is happening in a much more generalized way where we can basically point it at any other source. So that then made that a really easy decision too, because there wasn't really anything that we were locking ourselves out of. We still had a lot of ability to go in different directions. If we then found out, oh, there's stuff we didn't foresee that we didn't have the kind of experience or expertise to know at that point in time, that we can now still react to really flexibly.
So there's three things I can unpick from what you've just said. The first one is this idea of constraints. We talk about constraints in decision-making, the boxes that we make our decision in. And often the obvious constraint is I've only got a limited time or money. And what I heard you saying is a driver is, can I make a decision that doesn't close off my constraints too much? So I've got some more freedom down track. And that sounds like a smart approach. Then the second one is options. By keeping my constraints broad, I've got more options in the future. And one of the things we know from decision science is more options is better than fewer options in a given decision because our brains want to compare things and we need a bunch of stuff to compare to give us some confidence in moving forward. When I think about the third point, it's uncertainty. So what's a path I can use where either I reduce my uncertainty or the effect of my uncertainty doesn't force an outcome in the future. And that's a really sophisticated way of thinking about decision making. No surprise, given I've got an astrophysicist here. And it's a challenge I've noticed in my work since major world events like COVID, where everyday people are suddenly realizing how uncertain the world is. Uncertainty is a barrier to decision making. We want certainty as humans. And so anything that we think gives us more certainty gives us more confidence to make a decision. And often the default is we make no decision because the uncertainty is too great. So to be able to be conscious of the level of uncertainty and then go, well, actually, if I can see the impact of that uncertainty, that still gives me freedom to make a decision. And often that's the silliness. The silliness is the level of uncertainty has no bearing on the decision that we're going to make because we feel uncertain. We feel scared of making a decision. So I think that's a really interesting point to hear how all that plays out for you in your world of decision making.
Yeah. The thing that kind of clued me into thinking about things like this in the first place, when I was studying physics, specifically in relativistic physics, a lot of what you're looking at is the universe looks different from different reference frames, right? So if you're traveling really fast, space-time does weird things compared to if you're not moving. Vice versa, if you are next to something really heavy versus someone who's not next to something really heavy, the way you actually perceive space and time is going to be different because it warps that space-time fabric. Literally, if you're going really fast, think of things just like compressed. So distances look shorter, things look smaller. That's the rough way of thinking of it. When you're actually doing physics there, where you're trying to say, hey, I'm an astronaut on a spaceship traveling near the speed of light, and I want to try to calculate how fast I'm going to be moving when I pass by this other spaceship that's traveling at some other different speed, the answer I get is going to be different than the answer they get. But both answers are correct. But there are differences in the amount of math you have to do to solve that problem and get to the general equation of motion of that system. There's two other guys that I spent a lot of time studying with when I was in school, and both of them were better mathematicians than I was. So when we got into relativistic physics, they could just pick any reference frame they wanted and just brute force their way through all the
Right.
math. I had to be a little bit more strategic about which reference frame I picked. So I would spend more time trying to figure out like, hey, generally is the math from this reference frame going to be a little bit more straightforward or like brief than from this other one. I would end up pretty consistently choosing different non-obvious reference frames to solve the problem than they would. And I would have to do less math, but they wouldn't have to spend any time thinking about the reference frame. Part of why I bring that up is because the first couple of times we were solving these problems, I would also just pick any reference frame and discover that was not working out for me super well. So then I was like, okay, I'll take a step back and spend a little bit more time on this part of the problem to make this other part of the problem a little bit easier. But I could do that pretty much because I knew generally what was going to happen within the system. And that's something I apply a lot in software engineering and planning out what we're going to build and like trying different ideas, especially in the data science realm. Software is privileged in the fact that we can prototype things pretty quickly outside of obviously like modern LLM systems where you're looking at months to train and hundreds of thousands of dollars to millions of dollars to train like a GPT-4o. But in a lot of other smaller situations, you can be like, hey, generally I know I need to solve this problem. There's 5 different paths open to me. I know that there's going to be a threshold at which I don't actually know enough about the problem to make a good decision about it right now or make a reasoned decision about it right now. But I know that within a day or two, I can basically get to the point where I understand enough of the problem by building some of that initial solution that I can then make a better decision about what that next step is going to be. And obviously, if you're building a bridge, you can't really just prototype a bridge and then say, hey, does this work? There's software for that, and there's other kind of techniques to be used there. It's the most valuable skill set I picked up over the past bunch of years, pretty much being able to look at a problem and assess how much of the consequences of that problem or the details around that problem do I understand? And do I understand enough of it to actually make a really good decision on it right now? Or should I basically kick that can down the road, do a little bit of exploration, and then come back to making that finalized decision? Our engineering team, we have an emoticon that's just Bart Simpson kicking a can down the road. And we just throw that out all the time. And that's understood within our engineering team. If you're using the kick the can emoji, pretty much what you're saying is like, hey, we don't know enough about this problem right now, or we don't need to solve it yet, or we need to figure out these other things before we can really make a decision there. And that's just tacitly understood as like, okay, cool.
There's 2 other things you pointed to in there in the sort of generalized world of decision making. One is that decision to defer the decision. And often one of the things that can improve our decision making is giving ourselves more time or distance or perspective. And that might be because we're confident we might uncover something in the next period of time that reduces the uncertainty to a level at which it's okay. We can live with that uncertainty. And the other is this idea of we only need to get the uncertainty to a level at which is sufficient to help us have a level of confidence in our decision making. I use the term requisite a lot in decision making because it's very tempting. People want to go, no, I've got to get it down to the nth degree before I'm prepared to move forward. And often that last few percent to get to the nth degree burns up 90% of the energy, the time, the resource to get to a level of certainty that actually is well greater than we need to move on in a decision that's actually sufficient. It's good enough. It's requisite to solve what we want. And often the temptation, especially in organizations, people in leadership, no, I need to get more certainty, do more analysis, give me more data, drill it down further and further. And you've got way past the point at which it's actually going to make a difference to the decision outcome. So back to your choosing reference frames, I liken that to in the world of decision analysis, which is stop for a moment, step back, think about how you're going to make this decision before you're into making the decision. And I can hear your colleagues going, well, we don't need that piece. We know we can solve this via whichever I pick. So I'm into the solution early. Whereas what you're doing is thinking harder about how do I solve this problem before I then start solving the problem. And the opportunity for how am I going to make this decision compared to making the decision gives a bit of a distance from the decision. Challenge in decision making, of course, we're very emotionally connected to our decisions. They reflect who we are often in the world. And so the temptation to jump into the making of the decision before we've thought about how am I going to make this? Who might I involve? Which frame of reference might I choose is critical. Perhaps not surprising. You speak from the world of data science, and I speak from the world of the decision science. These are parallel universes. Perhaps we're the 2 spacecrafts traveling at different speeds compared to each other.
Yeah, I think people get caught up in the we need to make the perfect decision or like the quote unquote right decision. The engineering data science parlance for that is don't prematurely optimize. So if you see an engineer trying to be like, hey, we need to tick off this last 20 milliseconds in this response time, is that going to really make the difference for the user right now? Or do we need to work on something else? Or if that optimization part is hard, we have a lot of systems in our platform where the full optimization to handle terabytes of data is like a difficult thing to do, but we don't have any data sets in platform right now that are terabytes of data. And it's going to be a little bit more time before we really need to get to that point. So it's like, all right, let's maybe kick that, can down the road a little bit. Don't prematurely optimize that system when we're still trying to work out kind of what are some of the core elements of it. I think people do that a lot with decisions as well, where they kind of agonize over every last detail of like, I have to get the exact right decision. And once we say we're doing X, then we can't do anything different. We can't adjust or pivot at all as we learn new things about what's actually going on and the impact of that decision. And there are different contexts in which you have more or less degrees of freedom to do that in. So again, software, a great place to make a lot of decisions really fast, and you can roll them back really quickly as well. Like in our engineering team, we don't really have the notion of, hey, we're going to do this next big release that's going to be this like super well orchestrated, super planned, no user gets access to any new thing in there until we release everything at once. And we do much more of a kind of rolling iterative release. So we'll release a whole bunch of times every week. And a lot of the benefits to that is we can test new ideas as they're coming up and then get immediate feedback on, is the plan working? We have a plan for X really big feature. We're going to release some smaller versions of that feature way early on and then see, are people actually engaging with that? Is actually doing what we wanted it to do? And then we can move that really quickly and adapt that really quickly. I think a really important thing as well is getting comfortable with no one's ever going to make the perfect decision or the exact right call. And most of the times when you look at decisions that have been like perfect over time, most likely if you look at what was the original decision and what did that decision end up turning into after it was fully realized, are going to be very different things because it's just naturally going to change and evolve over time. Speaking of context, the philosophy of LLMs is, I think, a somewhat understated part of how we're going to end up interacting with them and working with them a lot. And context is a massive part of it, because the context you give an LLM is going to, by and large, override the rest of the parameters of that LLM and how it's been trained to work. Everyone's heard it's easy to lie with statistics. Like it's even easier to lie with the LLMs, because if you give them a context that is specifically worded to sound a certain way, then you can really easily manipulate the LLM to go into a different part of its answer space and then just pull an answer from there instead. So that notion of how do we make sure that as we're integrating LLMs and generative AI and all these other systems into our day-to-day lives and the decisions that we're trying to make, being really careful with what are we actually, one, giving that LLM to make its decision off of? Because if you use words that are negative in connotation or positive in connotation, it's going to latch onto that. Because basically the most intuitive way to think about things is if the LLM starts out with a big box of space, as you're giving it words, it's basically cutting off parts of that box to not look at anymore. And eventually you get down to, here's the full thing I said. And the LLM is going to have a very different thought space to use to answer that question. And which is a part of why when we talk about like prompt engineering and that kind of thing, you're very specifically using words in your prompts that are trying to guide the LLM in the right like direction. If you're saying things like act like a machine learning engineering expert, it's then basically going to shift the probability of any word that it generates to be more likely to have occurred in the same kind of context or source as the notion of a machine learning engineer. So they're incredibly easy to bias, which then makes transparency and what are you actually telling this thing to get an answer really important to be able to get access to.
This is a fascinating conversation. And of course, often people are asking me, what's the impact of AI on what I do and decision science and so on? And I've got my own views, and I'm very privileged to have you as an expert in that field, especially in the technological domain. But I got to ask you a couple of questions because I know some people are listening in and say, what is that? So when you say LLM, large language model, is that different from AI? Is that an AI? Is that a type of AI? What's the sort of 101 on that?
Yeah, it's a small subset of AI.
Right.
So when we think about artificial intelligence, really any computer program, any algorithm, any series of steps you could argue is artificial intelligence. And many companies will try to claim that and basically say like, we have a really simplistic system that's working in the background and it's linear regression, or it's a basically just nested if-then statement. Because even the most sophisticated neural networks functionally in the rudimentary code level are pretty much just a giant series of nested if this, then that, if this, then that kind of statements. So that's really all AI is. Large language models are then a very specific, not necessarily new, but suddenly popular and way more effective than we thought they were going to be a couple of years ago. And a big part of their surge in popularity is just that people can interact with them more. They're not really the most sophisticated AI that's out there. They're not really solving a lot of what we used to think of as core data problems, but they are by far the most interactable. All of a sudden, it's brought the kind of the world of AI and all the research that people have been doing for decades to the forefront of everyone can now log on to ChatGPT and ask ChatGPT questions and then have this interaction and experience with AI that suddenly like very obviously this is AI. In a lot of ways, when people talk about AI, if they're not like kind of practitioners, they're probably referring to LLMs and systems like that. But a lot of what we're seeing then starts to become combinations of these systems. So you might have AI analytics platforms. The really effective ones pretty much have LLMs that act as interfaces between a user and the data themselves. Someone will come in and be like, make me a graph of something. The LLM will then turn that into an SQL statement or some other kind of then programmatically determined interaction with data that just makes it way easier for the person who doesn't want to learn SQL or be trained on databases or doesn't have access to some of those databases from privacy concerns or security concerns, something like that.
I do want to ask you specifically about the role of AI or LLM in your business, because I hear that's a kind of core part of it. Just something I noticed, and you said it in a different way, but it just occurs to me from a decision scientific point of view. When we look at our biases and our context and how we experience the world, this idea of it's a human-like language interface where I don't have to think carefully about what I say. I can ask it a question. I'm guessing, and you'll have a view on this, I'm sure, my confidence in the response and my experience of the response is biased by the fact it comes back in a natural language.
Absolutely.
And I'm getting past this robot sounding voice, poorly constructed sentences to something that is a natural language response. And therefore my confidence in the response runs the risk of being completely at odds with the actual accuracy or precision of the response that I'm getting.
It's really like unnerving in some ways because it will double down too. It'll try to convince you that it's right occasionally. Or I've also seen it go the other way where it's given me a response and I've replied to it and be like, no, that's not right. And it'll come back and be like, oh yeah, sorry, here's the new answer. And it's the exact same answer. It can be really difficult to interact with. And it pervades a lot of how we perceive the systems as well. And AI practitioners, we're not really doing ourselves any favors by talking about this LLM thinks. Like we use very humanizing terms when we're talking about these systems. And they're fundamentally not. These are just giant, heavily tuned probability systems that just try to predict what's the most likely next word that's going to come out of here. And they're really good at doing it. But that doesn't mean that it thinks anything or that it like thinks it's right. So you can get it to take on different personas and it will really effectively take that persona on to the point where we can be like, oh, wow, this thing's actually really thinking and has like a view on this or like an opinion. You can ask it anything and it'll talk for as long as its prompt basically allows it to talk, because it's just getting new probabilities for every word as it's spinning them out. A lot of it is like phenomenally accurate and successful. It's just something we have to constantly be aware of. These are potentially misleading systems that are very tuned in to how we prompt them to engage. As you're using them for decision-making in businesses and anything else, you really have to be aware of, are you giving it a neutral prompt or are you encouraging it to lean in one way or another? What is it actually saying? And can you kind of fact check where it's coming from? So yeah, there's a lot of nuance in there.
That's no different from the human situation, except typically in the human situation, you'd have someone else overseeing that. I'm interviewing you, maybe you're a politician, and I'm prompting you with questions that are clearly leaning towards me, encouraging you to give some opinion that I want to hear. And then your chief of staff is sitting in the wings going, hang on a minute, I'm going to just interrupt that question because now we don't have that. I've done exactly that with my LLM. And once come back, I've gone, cool. Clearly that's unbiased because it's a computer, so it can't be biased. All we've done is we've created the bias. We've actually asked it to be biased. We've literally said, be biased and give me something back. And one of the strongest cognitive biases for us is a confirmation bias. As humans, we don't like being wrong. Of course, if I've decided the answer is X, and I ask something that clearly knows the universe, as in an LLM, to confirm I'm right, I'm going to get the answer back, you're right. And that's probably not helpful for anyone and actually doesn't create anything, which, let's say, the future is creation, right?
Yeah. And that's the other thing as well, is typically what we would expect out of a human reaction or human interaction is if you ask me a question about something I don't know about, the kind of honest, good standing citizen me will be like, I don't really know, but here's an assumption. The LLMs don't really do that. They'll just be like, here you go, here's an answer. And then there'll be like the caveat of fact check this, but it's definitely leading you in a direction where the monkey brain inside all of us is being like, they said this and I should trust that because of how it was delivered. But because it's just that probabilistic generation that becomes, we just need to fact check things. I sound a little bit like doom and gloom about these systems, but I'm really not. I think they're phenomenal. I use them extensively every day and they're fantastic tools. You just got to be careful about where you put them and what area you're going to get their help in, which then goes on to how do we use LLMs generally. So there's kind of two frames in which I interact with LLMs every day and other AI systems. One of them is I use them to do my own work more efficiently. And then the other one is as I'm building tools to help my clients get better access to the engineering platforms that we're building, or make it easier for them to interact with the analytics that we're generating so they can make decisions off the back of that. When I'm using them in my personal day-to-day, typically what I'm looking at is every time I go to solve a problem and I'm like, would an AI be able to help me here? One of the first kind of check marks, is this a common problem that's going to be reasonably easy to explain, but also have a lot of like evidence for how to do that thing available to whenever that AI was trained? If the answer is yes to that question, then that's a great kind of candidate for it. And that would be something like, I want to write an SQL query to do some statement. And I know I could put it together, but there's nested statements or whatever, and I don't really want to deal with it. Then I can just have that generate it and then move on to the next kind of bigger value add part of integrating that to the larger system. If I'm looking at, we need to build a new permissioning system or something like that, that's not necessarily something I'm then going to take to an LLM or any kind of AI, because the context requirement for what do we actually need out of that kind of system, how are we going to integrate it with all of our core information, it's not stuff that system's really going to have access to. So I'm not really going to trust anything that it generates. And I'll still use it for little bits of that, but the overall kind of concept of it isn't something I'm really going to lean on an AI to help out with. That's kind of what we tell our customers as well, is these systems are there to be like interaction aids, and they're there to help you do more in less time and get more access to information and kind of be unblocked by the pedestrian tasks, for lack of better words, of just, I just need to do X or get a view on X. But when you're going out into the really large scale decisions or the really impactful things that require a lot of context from a lot of different situations or stakeholders, that's where those systems become substantially less capable of dealing with that kind of situation, just because the information requirements.
Fascinating to hear that. Thank you. When I translate that into the question, of course, AI is going to overtake decision making. We will no longer need to make decisions because they'll be made for us. I don't believe that. I look at how decisions are made, and I look at how do we optimize the part that the human does and let the data and the technology do everything else. And as you say, can they improve our speed of doing something because we're not doing the more pedestrian activities? And I heard two things you said. One thing is the decision when to go to an AI. So you've got a clear decision process. Is this a problem that's well solved, that probably it's got a large evidence base to draw on so I can have more confidence in the outcome? So there's a criteria for your decision as to whether to use an AI. And then I'd say there's another decision, which is what to do with the result you get. Because in any decision process is you don't go, you follow it through, there's the answer, therefore that's the answer. You follow it through, this feels like the strongest answer, the most preferable option, the most interesting approach, but I still have other answers behind me that I can compare that against before I commit on that answer. And that sounds like a risk with something like an LLM. I've gone to ChatGPT, I've asked it to make this decision. It said the answer's this. Well, we've got no basis for going, why that compared to something else. And the one thing I do know about LLMs is you've got no ability to then drill inside and say, how did you come to that decision? Am I correct in that?
Yeah, it's really difficult to do that. Definitely, there are a lot of groups working on that kind of transparency in these systems, but it's super challenging. There's 1.4 trillion parameters inside of GPT-4o, I think. It just becomes something where, trying to figure out like, hey, exactly how did this really complex general set of text propagate through this network is really difficult. And then trying to assess that at scale. So even then, how do we evaluate if an LLM or an AI is like good, right? Phenomenally difficult, because you have an unbounded, unstructured input, which is just someone asking a question. And then you have a fundamentally unbounded and unstructured output, which is then the text that responds to that. Beyond even just, should I use an AI for this? That's the first question that everyone should kind of ask, as you're looking at how do we navigate around this space. That's the first check mark. Is this something that's going to require a lot of context that's not readily available in text that I can funnel into this thing? If it requires a lot of context or requires a lot of kind of like human interaction or human intuition, then don't rely too heavily on AI systems to generate that, because things are going to get weird. If it is something where you're like, oh yeah, I just need to give it these 7 documents and I need it to tell me where the document's different or summarize the documents so that I can have a shorter list of things that I need to read. They're phenomenally good at that. Text summarization, text comparison is a discipline in natural language processing that's been relatively well solved for quite a long time. And then language models have just made those tools extremely accessible to anyone who wants to interact with them. So those are great uses. Once you know, okay, yeah, cool, we have something where we're going to use AI to help with this, then you get to the next decision point of, great, which AI are we going to use? So you have Llama 3, Claude, ChatGPT, Gemini, like there's a huge number of options for them. One of the things we're really struggling with generally as a field is how do we compare these models against each other? So we have a number of benchmarks to try to do that. But then often what you'll see is each of these models has a 4 to 8% difference in performance on all these different benchmarks. It's hard to then say, okay, cool. Yeah, this model then is just objectively better because it does better across these benchmarks, because the benchmarks don't actually evaluate everything, and they might be totally irrelevant for whatever use case you're trying to actually solve, because there might not be as much training data available to these systems in what you're trying to solve. But even then, it's difficult to tell, is there enough training data? Because it's like most of the internet is the training data. So that's a difficult question to answer. This is one of those decisions where I would say don't spend a lot of time trying to figure out, should we use OpenAI or Claude or any of these other systems? If you're trying to experiment with including AI in your day-to-day workflows, just pick one that's either going to be technically the easiest for you to integrate or the cheapest, and see how it works, see how it behaves. This is very much one of those situations where experiment first and then make a committed decision like later on. Because you might find for your particular use case, one, you don't need GPT-4o or Claude or one of these huge models that are really expensive. You need a really small, stupid model, but it does exactly what you need it to do. So there's a lot of ways to then play with how you're actually going to implement these systems. And the best way to understand, is this the right model for my use case, is to use all the models in your use case, figure out how to evaluate them against that use case, and then just pick whatever evaluates well there and just totally ignore all the other benchmarks that are coming out. So it's much more like general capability systems.
Obviously, this is a decision clinic, and generally people bring decisions to the clinic that they're grappling with. Would you say that's something that you're hearing, you're seeing is something that's worth a little bit more of a digging into?
Yeah, let's do it.
So with that in mind, one of the things I'm always listening for in any decision is, what are the trade-offs? If I can have more of this and I got to have less of that, what do those trade-offs look like? So there's obviously some kind of cost thing, because many people would have no idea. Where is the cost in these things? Is it licensing? Is it compute? What is it?
A lot of it, it's going to be the actual compute. Right. And the way that's priced typically is like per token. So if you send in a question that has 10 characters in your question and the system spits out, like tokens aren't exactly characters, but you can think of them as a kind of a relatively easy comparison. And you're going to average probably like between 3 to 5 to maybe 6 characters per like word over a large sample. So you're pretty much getting priced on that. If you send in 10 words and it gives you 50 words, then that's the pricing you're looking at. You'll get charged for 60 words. Typically, that's not really going to be an issue if you're doing just purely internal stuff, unless you have like massive internal, like you're expecting this to get a ton of traffic. Right. So that's also one of the things to consider. If you have a relatively small use case that's going to be used by dozens of people or hundreds of people, then pricing shouldn't really be that much of a concern. These things shouldn't be that expensive. If you have thousands to tens of thousands to hundreds of thousands of people who are going to be interacting with this, that's where it becomes a much more of a priority in your decisioning.
So cost is clearly one driver, depending on the scale of your expected use case, et cetera, et cetera. Then you talked about performance. What's that about? Is that something to do with speed of how quickly things are returned? Or
yeah, so it's a bit of both. There's definitely a performance difference between all the models, but it's still pretty small. And that performance is the actual, I send in 10 words, how quickly do I get a generated output? Then the other part of performance is that generated output good. And I specifically say good because in a lot of situations, I want to do away with the notion of accuracy for these models, because unless you're doing a very specific task with them, accuracy is going to be like less important. If you're doing a very specific task with them, you're going to measure accuracy differently. I don't mean this by it gave me back the correct fact. Trying to figure out how would you measure if I say to the AI, what should I do today? How do I measure the accuracy of that response? Pretty much just going to be a personal decision basis of, it gave me some suggestions that are, one, either are reasonable suggestions that a human who doesn't know me would give, or two, I like it because it specifically mentioned one of my hobbies and therefore Claude is better than GPT-4o or for some kind of arbitrary reason. There have been many times where a model will come out, it'll get a lot of hype because it's now the best performing model across all the benchmarks. Then you'll hear basically a 50-50 split of people using it, whether they actually like it and think it's better or whether they think the old model was better. And part of that might also even just be, I got used to how this model gives its output, so I can parse it faster. I get more information out of this response and this response, therefore this model is better.
Yeah, so we're back to context that you're operating from in terms of what you see coming back from your AI and your experience of, do I like it or not? And this idea of goodness or how much you like it it's fascinating. In the world of decision making, that's a very human phenomenon that actually is unlikely to ever be replaced by an AI. This experience of what I'd say is value judgment. Is this better than this? The idea of your experience of whether it's better than something, It's what has us tick as human beings. And our opportunity in decision making is to go, that's the stuff we're good at doing. All the other stuff, like bringing huge quantities of information together, trying to make sense of it, trying to pick the bits out of it, that is awesome for technology to use. And data science has given us access to that. And you put AI on top of that, then you've got a way of supercharging what we as the humans can do. And then there's the bit the humans still need to play, which is, it doesn't pass me to notice that this challenge of evaluating them, you could give that to an AI, right? You could go to ChatGPT and say, give me a model for evaluating different LLMs. Yeah. Where would that go? Would that disappear up its own backside? I don't know.
Yeah. The weird thing is it'll just tell you whatever it sees most on the internet. That's one of the other things about these systems is they are probabilistic systems. If they see thing X a lot and they see thing Y 5 times, then they're going to give you X, even if Y is actually the correct thing. So they're really difficult to kind of police in that manner. If you take a model from a year and a half ago and ask it some of these questions about who has the best LLM or where's the best place to use LLMs, before we had a lot of literature and thinking and people discussing what do you do with these things, it's going to give you a way different answer than the modern systems. It's not that those aren't accurate either. Like they could theoretically be better models that just don't have access to the information that the newer models have access to.
Yeah, that's my limited understanding is you got to look at the two halves of the equation. There is the what's it got access to, where does it go to find the content, and there's the bit that's spinning around doing the looking for. And is that, again, am I oversimplifying this?
No, it's pretty accurate. A lot of the evaluation for this is really going to be, does this model do the job? And it's not going to be this model does the job 7% better than this model, because in a lot of our use cases, we're not actually going to really be able to measure that. It's going to be this model has a really convenient API to work with, or this model integrates nicely with all of our other stuff, or we have a massive discount on this model, so we'll use it. It's way less of there's going to be a clear winner, a clear best thing. Obviously, if someone randomly comes out with true artificial general intelligence, we'll have a very different conversation then. And that is a conversation where we could actually have that with the LLM in a reasonable way. But AGI, I think, is still quite some time off. AGI is artificial general intelligence, which is the notion of a AI that has human equivalent intelligence and the ability to learn, actually think, actually question itself, do things that like current systems don't do. That will be a very intense period of time when those start coming around. I still think we've got some time before that.
In our lifetime, do you think?
In our lifetime, potentially. One of the other big challenges, and I've veered away from evaluations, but I think it's really important that people start being comfortable with how we talk about these systems and get away from some of the hype cycles and into the reality of some of these systems.
Which is another context thing, right? The hype cycle is an availability bias that has us go, everyone's talking about this must be the way the future's going. And now my response to that is given by the hype in the beginning. So that's another decision-making phenomenon that's important for us to point to.
One of the things that's talked about a lot is how much better are these models going to get in what amount of time? We saw a massive rise in capability of these models over the past couple of years. And there are people out there saying this pace of innovation and improvement is going to continue. And there's an equivalent amount of people saying there's no evidence of that. It's seeming like there's evidence to the contrary, that these systems aren't going to improve at the rate we've been seeing them, unless there's some kind of new innovation that's brought to the table outside of the current probabilistic nature of LLMs. I'm in that camp, that there's no guarantee that these systems are going to evolve as quickly as they have, that we are seeing phenomenon of you need exponentially more data to get smaller improvements in quote unquote performance. And that's like the benchmark performance. So that's one of the things as well, is it's really difficult to say where these things are going to go, because we could start getting to the point where getting improvement out of the systems is just too expensive that it doesn't make sense. So we need to find like a different modeling approach to build these things out. Not to say these systems aren't going to become more useful because people find better ways to integrate them. So now a lot of the innovation is on, rather than have one big model, what if we have an array of smaller models that we have an interface to, where when a question is asked, the system figures out which model would be the best to handle this kind of question or this kind of statement, and basically tasks a set of other models with solving that thing or generating the final answer. I think a lot of the innovation we're going to see over the next 6 months to a year is going to be much more on the how do we build interfaces and integrations with these systems that are going to make them more capable and also safer to use, as opposed to the just here's X new big model that's X% better.
Cool. Well, this has been a far-reaching conversation, and I'm just noticing that my light's flashing saying my next patient's ready to come into the clinic, so we do need to wrap it up. I guess what I'm taking from the conversation is, firstly, there's so much parallel in the world of decision-making and the world of data science, and then AI and LLMs, and that we got to maintain a human perspective on it. And when we start to look at making certain decisions around maybe what technologies I might use or how I use them, it comes down to the same things that we always know in all decisions. Firstly, be clear on what might my criteria be. Is cost a factor for me? Do I have this idea of accuracy or performance? Let me get clear on that before I jump in, and also give myself some options. And as you pointed out, one of the things that technology allows us for is to try an option out quite quickly and then have a view on it. Of course, we need to know, how are we going to come to that view? It's no good trying something and then going, well, I don't know if I like what I got or not. So, and beware the cognitive bias, the sort of, I'm already biased towards that because its turn of phrase happens to be familiar to me, so I'm more predisposed. And I guess your early point, which is very similar in the world of options generation in decisions, is the whole prompting thing. I can set it up to tell me what I want to hear, which is probably not actually going to be that helpful for us in decision making. Sounds like to me that AIs and LLMs are great tools in assisting us. We call them decision support, let's say, and they're not there to take away the role of the human being in this thing. And in fact, the opportunity for us is to learn how better to make sense of what we're learning rather than just take it as read. How's that sound?
Absolutely. And I think the work that you do around putting rigor behind making decisions is going to become increasingly more important because of these systems' ability to generate any option that you want them to generate. If you go to one of these systems, say, give me 10 options for X, it'll give you 10. You say, give me 10 more, it'll give you another 10. Having then that structure to whittle all of that down into what you actually need to be considering is going to be increasingly important as these systems propagate and become more and more verbose.
Awesome. Thank you so much for coming in, sharing this. I've learned a ton today and lots of acronyms too. Thanks very much indeed, Will.
Awesome. Thanks for having me.